Oh, the ambiguous case of the sine law. Ambiguous case means that we can end up with more than one triangle, more than one thing can happen, okay? And this will, well, it won't necessarily occur, but it could occur when the information that's given to us about a triangle is angle, side, side in that order. Or if you want to just reverse things, you could say side, side, angle. But it's more fun to say angle, side, side, because then you can abbreviate it like that if you want, right? You could also do it this way, side, side, angle, go in the opposite, you know, switch them all around, but whatever floats your boat, okay? So let's just see why this happens, okay? So let's say we have an angle, A, that's given to us. So the idea is that this would be angle A along here. And this is the angle that we know. We know side B is along here. And then side A, which would be opposite to angle A, is also given to us. We know the length of side A. And the idea is that this side A could hit there, but it could also sort of swing around like this and hit over there as well. Okay, so we can end up with two possible triangles. We can end up with this triangle that looks like this. Or we can end up with this triangle that looks like this. Right? And these are the same. Now, really, the reason that this happens is the fact that sine is positive in quadrant 1 and quadrant 2, right? And so what you may notice within here in this drawing is that we have this sort of isosceles triangle. And so this angle and this angle are the same. And so these two add up to 180. Right? And so you have the sine of this angle will be the sine of the same as the sine of this angle because they have the same reference angle. That's essentially why this occurs. Okay? Now it'll only occur in certain situations though, because we also within a triangle have certain constraints that don't always allow this. For example, we have angle sum of a triangle, right? We are limited to 180 degrees within the angle sum of a triangle. So if, for example, angle A is too big, the angle that we're given is too big, then we won't get the ambiguous case of a sine law because of that reason. Okay, so we have to kind of identify, this would be our side A, when this could possibly occur so that we can learn how to identify it, right? So we can be like, okay, what do we need to look out for so that we can see if this may be the ambiguous case of the sine law, okay? So the first thing that you want to look out for is what information are you given? Are you given an angle and then two consecutive sides? If that's not what you're given, if you're given two angles and a side, you don't need to worry about it, okay? Or if you're given a side and then an angle and then a side. So you're given the angle between two sides. You don't need to worry about this, okay? So the very first criteria that you need to look for is angle side side. That's the first thing. But then there's some other stuff that you want to look out for to see if this could happen, okay? And so essentially, not always when you're given the angle side side, when you're in that situation, will you get the ambiguous case, okay? It'll only happen in certain scenarios. So there's a couple of possibilities. Well, there's actually more than 3 possibilities. There's more like 4, well, I'm not even going to write 3. I'm going to write several possibilities. Okay, so the first thing that could happen when you have an angle, and actually I should draw this sort of base side dotted, because that is the one where we don't know how long it's going to be, right? And we saw that up here. If you do have the ambiguous case, the 2 sides that are given are fixed, right? But the base of the triangle is going to change lengths, okay? So I'm actually going to make the base like a dotted line, because we don't know what that's going to be, okay? And the other line that I'm going to draw in is the height of the triangle. Because the height of the triangle will be important for determining what type of situation that we're in. Okay, so this over here is angle A. Side A would be opposite to it. So it's going to be kind of hanging off of this point over here. It's going to be attached to this point. This would be side B. Okay? The first case is that side A is actually less than the height of the triangle. If A is less than H, okay, if you can imagine a side length that's less than H, right? And it's just kind of hanging there. Could I even get a triangle here? Is this ever going to touch this base? No. So if the opposite side, side A, is less than the height, there will not be a triangle. No triangle exists where this is possible. So there's no triangle in this situation. It's impossible. Okay. The second thing that could happen, I'm going to start out by drawing the exact same thing. So here's my sort of dotted baseline. It should look the same, but my drawing skills are not very good, so apologies there. There's angle A. Here's side B. Here's my height. Is that A equals H. So if the opposite side to angle A is the same length as the height, how many triangles could I get? Yeah, 1, exactly. I'm going to get 1 triangle, and in fact, it would be a right triangle, right? This would also be side A. They're kind of overlapping. And I would get 1 triangle, and it would be a right triangle. Okay? And then the third possibility oh, wait, this is going to be dotted, sorry. Here's my height again. The third possibility is that side A is in between the height and side B. Okay? Oh, wait, I want to switch back to black. Ugh. This board is driving me nuts. Okay. So if side A is somewhere in between the length of B and, the length of H rather and the length of B, okay, it's longer than H, but it's shorter than B, then what could happen? How many triangles could I get? Yep. Not an infinite number, because A is not anything, like it's a fixed value, but it has to be somewhere between these two. So it's not anything, but it's a fixed value between the height and this side over here. Yeah. You can get 2, exactly. So you could get 1 on this side. But if I reflect this line over this height line, then I also get 1 on this side. I get 2 triangles. And this is the ambiguous case. Okay, so this is kind of key, because what we also need to look out for is we need A to be less than B, right? So we need the side that's opposite the angle given to be less than the other side that's given. So when you're looking at this angle side-side situation, right? Here's our first angle. This is the side next to the angle. And then the next thing would be the side opposite the angle. This side must be less than this side. Does that make sense? Okay. Now, let's see what would happen if it's greater than. Okay. If it's greater than, and also if side A, if angle A is obtuse, right? We haven't actually looked at that scenario. Okay. Well, if angle A is obtuse, here's angle A over here, right? Then if A is less than or equal to B, okay, so we'd have this situation here. Here's B. Here's angle A. A would be like this. Could we get a triangle? No. And actually, we'll talk about why in a second after we finish looking at what happens if A is greater than B. And if A is obtuse and A is greater than B, so here's B, here's angle A, here's side A, there's only one triangle that's possible. Okay, now, why is this the case? Well, if A is an obtuse angle, the other two angles have to be acute, right? Because the angle sum of a triangle is 180 degrees. If A is obtuse, it's already over 90, which means the other two angles have to add to less than 90. If two angles add to less than 90, they are both acute angles. When you have the ambiguous case of the sine law, that relies on one of the cases having another obtuse angle. Okay, so when we saw on the previous page over here, right, when we saw these two cases, in one of the cases, when you have an ambiguous case, you must have an obtuse angle. Okay, if your angle A is already obtuse, there's no room in the triangle to have another obtuse angle. You can't have two obtuse angles in a triangle. So if angle A is already an obtuse angle, you will not get the ambiguous case of the sine law. Okay? So that's another thing to look out for. If angle A, if the angle that you're given is obtuse, you won't get the ambiguous case. Okay? Now, why won't this work, right? Why won't it work if A is less than B? Well, you can kind of see from the picture. But we also saw yesterday that the largest side of an angle, or the largest side in a triangle, is always opposite the largest angle. And so if A is an obtuse angle, it will be the largest angle. Therefore, side A must be the largest side. And so if side A is smaller than side B, but A is an obtuse angle, that won't be a triangle. It's impossible. Okay? And so, sort of in summary, what are you looking for? You're looking for angle, side, side. And I would highly recommend drawing, right? Drawing is always, always a good idea. You need to have an angle, a side, and then another side. And also remember, it could be given to you in that order as well. Side, side, angle. Because you can sort of rotate things in a triangle or go in the reverse, like go counterclockwise or whatnot, and you're going to be given sort of the same information. Okay? What else? Well, this, what type of angle does that have to be? If you could have the ambiguous case. It has to be acute. If your angle is obtuse, you will not get the ambiguous case. Because if you have the ambiguous case, one of your two triangles will have another obtuse angle in it. You can't have two obtuse angles in a triangle. So this must be acute. I think that only has one C. I have to fix that. I don't have to fix it, but I want to fix it. What about the two sides? Does it matter, like, if one's bigger than the other? Does that matter at all? Yeah. Which of the two sides has to be bigger? The last one. Yes. This one must be smaller, and this one must be bigger. This is what you're looking for. if you have an ambiguous case of the sine law. Okay, and one of the hardest things to do actually is to sort of diagnose the question, right? So here's a triangle, especially when they're not actually giving you a diagram and you just have to kind of, here's some angles and here's some sides in a triangle, draw it, or just determine how many possible triangles there could be kind of thing. Those are some of the hardest ones to do because you have to determine what's going on here, right? Yes? If it's side-side angle, you just kind of turn this whole thing around, right? So the idea is that the biggest side has to be opposite the angle. So it's going to be the one, like there's a space in between. Yeah, good question. Okay. Are you guys ready to try one? Yeah? Okay. So here's an example. In triangle ABC, angle A equals 6. A equals 6, B equals 8. What is angle B and angle C to the nearest degree? Oh, I'm sorry. I mixed this up, didn't I? This has to be smaller. Because A has to be less than B, right? A has to be between the height and B. I made a mistake there. Didn't I? Sorry about that. So the side that's opposite the angle has to be smaller than the one that's beside the angle. Yeah?
If it was above, or if A was larger than B, would it still be an ambiguous case?
If A was larger than B, then I believe you would only have one triangle. Yeah. If A was larger than B, let's try it. Let's try it. Whoops. Here's side B. Side A is larger, right? So let's say it's like this, right? Now if I swing that around, it's going to hit on this side. It's going to hit, like, here's my line. Here's angle A, right? So it's almost like swinging a pendulum, right? So if I swing the pendulum along this baseline, and, well, actually, I should make it more like this. It's not going to work because here's my baseline, right? If A, here's side B. If A is larger, like that, and I take this pendulum and I swing it, it's going to hit on the wrong side of the angle.
But doesn't that also make a triangle?
Well, it makes a triangle, but not with this angle. If this is the angle that you're given, that's set, right? So yeah, it'll make a triangle that looks like that, but that's not with the triangle that you're given. Does that make sense? Yeah. So A cannot be larger than B to have an ambiguous case. If A is larger than B, then that's it. You have one triangle. Okay? All right. So I'm sorry. I messed that up. This has to be bigger. This one has to be smaller. Right? Because for this very reason. And this can be a really helpful thing to do, is to imagine that this is fixed and then side A is hanging off like a pendulum swinging back and forth, right? And so if side A is smaller and then you swing the pendulum around, will it hit the base twice before it gets to this angle? If it hits twice before it gets to that angle, you have two triangles. Does that make sense? Okay. All right. Okay. With that in mind, let's try a question. Okay? So in triangle ABC, angle A equals 39 degrees, A equals 6, and B equals 8. Okay? What is angle B and C to the nearest degree? So firstly, just to try and identify if this is an ambiguous case of the sine law, one thing to think about is, are we given one angle and two sides? Which we are. Okay, so this could be. Yeah? No, you could be given like angle B and then side B and side C. That would be fine. Right? That would also could be an ambiguous case. Right? It has to essentially be an angle and then two consecutive sides that come after that angle. But the lettering doesn't really matter. Right? Yeah. Okay. So we have angle A, side A, and side B. Okay? What is angle B and angle C to the nearest degree? Okay? So we don't have to do this, but it's a good idea to sketch this. So first we have angle A, which is 39 degrees. Also, this is acute. So we could be in a situation where we have an ambiguous case of the sine law. Okay? So angle A is 39 degrees. Side B, which would, if this is B over here on the right, side B would be over here. And then side A is hanging off of here. Okay, and that's 6. So that would be less than 8. So if you can imagine this swinging around, that could hit over here as well. Okay, so this will result in the ambiguous case of the sine law. Okay, now what's going to happen is we're essentially going to get two different triangles. We're going to get one triangle with 3 acute angles, and that's sort of the bigger one. I don't know if you'd call them, well, it is a bigger one. It's bigger in size, right? And then we have this smaller one sort of on the inside. Okay, so what I'm going to look at first is the bigger one, because when I use the sine law directly, I don't sort of have to do any other work to just get that triangle. Okay, so I'm going to draw those two triangles separately. Once I establish that I'm dealing with an ambiguous case, I'm going to sort of do this in 2 parts. Okay, so I'm going to look at my first triangle, which looks like this. Here's A, this is 8, this is 6, and this is 39 degrees. Okay, this over here would be B, and this is C. And this, of course, would be side C. Okay, now we have been asked, I believe, for angle C and angle B. I think that's what was asked for, angle B and angle C to the nearest degree. Okay, so we can use the sine law here because we have this pair of A and angle A and side A, and we know side B, so we could find angle B first. And so I'm going to set up like sine A over A equals sine B over B. And I'm going to fill in what I know. So I know that A is 39 degrees, and A is 6. And I don't know what B is, so sine B over 8. Okay? And so then to get sine B, I would need to multiply both sides by 8. And I'll get that sine B equals sine 39 times 8 divided by 6. So if I want to get B, I take the inverse of that, right? So B is going to be sine inverse of 8 sine 39 over 6. This time I'm going to make sure my calculator is in degrees. Okay, and what did you guys get? What'd you get? 57, no, yeah, that's what I got too. So I got 57 degrees. Okay, so if that angle is 57 degrees, then what would angle B, or angle C be, rather? What's that? 84? Okay, so how'd you get that? Yeah? There you go. So you use angle sum of the triangle. So you go 180 minus 57 minus 39, and that's 84? 84 degrees. Okay, so there we go. We get angle B and angle C. Okay, now, to do the second triangle, we use what we found in the first, which is the fact that this guy over here is 57. Okay, and this triangle, I'm going to draw it sort of in red. Is an isosceles triangle. Because remember that this is 6 and this is 6. So what would this angle down here be? If this one was 57, that was sort of in the triangle that we just figured out, what would this angle be? Also 57. Okay. So again, this is not in the triangle that we're looking at now, but that gives us this angle. What's this angle right here? Yes? Exactly, 180 minus 57. So this is 180 minus 57, which is 123 degrees, right? So this is our new angle B in the second triangle. Okay, so in this triangle, this is still 39, right? This is A, this is C, this is B. Angle B is 180 minus 57, which is 123. And angle C is 180 minus 123 minus 39. Say that again? 18 degrees. Thank you. Okay, now this will always be the case. Okay, so in the second triangle where you have the obtuse angle is always found by going 180 minus the acute angle that you found in the first triangle. And essentially that's because of the fact that sine is positive in the first and second quadrant. And so this angle over here, right, if you think of it in terms of angles in all four quadrants, your reference angle is this same 57 degrees. So how do we find the angle in the second quadrant? We go 180 minus the reference angle, right? So that's exactly what we're doing here. We're going 180 minus the reference angle because these two angles together add up to 180 degrees. Okay, now you don't have to remember all that, but you can see why the fact that this forms an isosceles triangle, this happens to be 123 degrees. Okay, does anyone have any questions around that? Now, what I was thinking, I think I'm going to stop the video here. But what I was thinking that we could do is perhaps do one question from the textbook together that's basically just about diagnosing the question, how many triangles are you going to get? Do you want to do that? Okay, so I'm going to stop the video, and then we'll look at that together.